My name is Ben Surato, and I am a student at Baker College studying supply chain management. Today, I will be presenting my findings on the inventory modeling system of an anonymous organization. Located in mid-Michigan and established in 2006, this 8-year-old organization employs around 50 people and supplies over 600 customers in 37 countries around the globe. They are involved in 3 major markets and manufacture 4 product lines: graphene nanoplatelets, silicon graphene composite, graphene-based sheets, and conductive inks. In terms of market demand for product, there is commercial business available, but this organization has yet to establish any major accounts. At this point in the development of nanoparticle technology, graphene-based products are thought to be in the late introductory period of their life cycle, verging on the growth stage. As for supplying the market with product, daily operations run at 100% capacity given their available equipment and labor. Ultimately, it has been determined that their production facility is capable of producing nearly 80 tons of manufactured goods annually. Surprisingly enough, they do not schedule their production based on forecasted demand from historic sales data. This organization instead is structured on a build-to-order basis where the majority of production demand is acquired through anecdotal, executive opinion, and market research qualitative forecasting. While there are repeat customers, those customers seldom order the same product. Only a small volume of product orders randomly are placed through their e-commerce web store, and managing daily production is mostly a long-term reactive as opposed to proactive system. Both raw material inventory and finished product output is managed with Microsoft Excel and Microsoft Access-based software. Their raw materials consist of carbon and proprietary chemicals purchased in bulk. All incoming inventory is manually entered on receiver logs, then transferred to Excel spreadsheets. The tracking of inventory levels is based on simple math. Known weekly consumption of raw materials is subtracted from known quantities using an Excel spreadsheet. Reorder points are different for all raw materials. For this organization, raw materials exhibit characteristics of dependent demand. However, consumption will vary day to day and is not a 1-for-1 ratio. As such, the economic order quantities do not support equally spaced reorder points, which is to say that some materials are ordered more frequently, some are ordered less frequently. Reorder points vary and are calculated based on expected production demand compared to known quantities. Vendor relationships are well established, so delivery is typically consistent. However, keep in mind that production schedules are flexible. This means that weekly consumption can unexpectedly fluctuate, leading to situations of both stock out and overstock. Although delivery can be a detriment to drive stock out, because the raw materials do not have shelf lives, there is no need for first in, first out, product cycling, or concern of overstocking materials aside from the capital investment. The finished products that are produced include various grades of graphene, graphene-based sheets, and conductive inks. Production schedules are based on known demand. Once an order is placed, or once the senior management team determines a potential demand, that order is placed in the production log. There is only one production line for all products, so estimated lead times and delivery expectations will vary product to product and may change over the course of time. Fluctuations in demand may drive deviation from production schedules in order to accommodate higher demand between product lines and customers. Because the production schedule is a direct result of demand, all finished products are made to order and are slated for sale. There is no long-term or shelved inventory of finished product. Everything that gets approved by quality assurance is shipped to customers. The SWOT analysis I performed on the inventory modeling system produced many key points. To begin, I identified many strengths. No long-term inventory for finished products, keep holding costs low, and reduces the need for increased floor space, shelving, or warehousing. Output capacity is a known variable. This allows for easier management of raw materials through materials resource planning and bill of materials systems. The flexibility of the production line enables this organization to easily switch between various product lines, whether to suit demand or adjust for raw material inventory availability. There is no legacy inventory management system to follow. As such, they are able to build their inventory management system based on company growth and demand as opposed to working within the constraints of a conventional system. There is no demand. As for weaknesses, there is no demand forecast driven by historic data. Production planning is entirely based on anecdotal and sporadic e-commerce sales orders. they have no commercial customers. Because graphene is yet to be established as a true commercial product, most end users are research and development firms, universities, and national governments who purchase small pilot volumes of product for the purpose of experimentation. As such, they must remain flexible in the array of products until commercial customers are established, at which point large volume orders for off-the-shelf products should become available. Another weakness is that they run only one production line to support sales. This structure is proven to be useful, but restricts output to build inventory. Production schedules can change frequently. This may disrupt production planning by affecting inventory levels of raw materials unexpectedly. The use of Excel and Access to record material, sales orders, and transactions is a manual entry system prone to human error. On a final note, raw material vendors are limited. In the event delivery is not available, alternative vendors are not common for proprietary carbons and chemicals. There are a few opportunities they can take advantage of. Stemming from the abundance of available commercial business, there is the opportunity to build a sales base. In doing so, repeat orders will not only provide historic data to help forecast sales, this will also enable the production of off-the-shelf products driven by the need for expansion of production capabilities. Similarly, expansion efforts should initiate the focus of building inventory for sales, reducing customer lead time, and expanding packaging capabilities for a more diverse value-added supply chain. Other opportunities include the sourcing and implementing of advanced software to manage inventory and for processing orders, reducing human error, and increasing efficiency. The single largest threat they face is the best problem any company wants to have: more orders. There is no forward-looking system to demand forecast, and only one production line with a known capacity to support various products. The onset of an unexpected order is not impossible given the potential for commercial business. However, because they do not keep stock inventory and currently operate at 100% capacity, one or more coinciding large orders that surpass equipment, labor, and raw material capability may be detrimental if the proposed delivery time for the product exceeds customer expectations. This is not only an inventory management issue, but also an operations issue. A final threat to the current inventory management system is that of human error. Current raw materials and sales orders, supported by Excel and Access, are prone to data entry issues. In conclusion, I recommend the following. Take advantage of the strengths and continue to run lean with low to no inventory. Sustain flexibility during product development in order to maintain a competitive advantage. And work to develop an inventory management system based on software that can grow with organizational necessity. Improve on the weaknesses. There needs to be an alternative plan for supplying raw materials in the event production schedules suddenly change and inventory is depleted. Reduce the chance for human error by incorporating automated software to process sales orders. This should eliminate some risk on the production end of operations and allow for better managed raw materials inventory system. Capitalize on opportunities. Locate and gain the business of available commercial customers and expand operations. In doing so, they will be able to build a database of repeat orders that will support forecasting demand and increase profit. They need to prepare for threats. Making the transition from a pilot to full-scale production company requires demand. However, any sudden demand that exceeds both capacity and customer expectations in delivery may actually result in the loss of business. In terms of inventory control, scaling up operations involves increasing raw material levels and final product inventory management to support production and delivery. There needs to be a plan in place that they can implement if needed. Finally, remove the risk of human error. Work to improve lean management of inventory-driven functions so human error becomes less of a threat to inventory control. Thank you for your time today.